afternoon to everyone. We have discussed in a previous class about impulse, and we found that impulse is expressed as the average force of the time, or it is also the change of momentum. So today we're going to discuss about the conservations of momentum. You can note down the headline, that is conservation of momentum. These things we're going to discuss, conservations of momentum. Earlier in the previous classes of your class 9 and 10, you have studied about conservations of energy, or all these things you have know, and you also understand what is conservations mean, as we have studied about the concept of conservation of energy, that energy cannot be destroyed nor be created. Hence, it has been transferred. It can be transferred from one form to another form. Same thing is also going to be happen for momentum, that you cannot destroy the momentum. Hence, the momentum will remain same if you consider two objects, and two objects are colliding each other. So after collision, that body will have some particular momentum, and before collision also, that those two body will have some momentum. So after collisions and before collision, the momentum will remain constant. That means momentum will not be changed. That is called the conservation of momentum. You can write that momentum of a body, momentum of the body, momentum of any two body will remain same after collision and before collision. Collision means what? They're colliding between each other. Okay, you can write that momentum of two body will remain same after collisions and before collision. So we're going to prove this one mathematically by showing some diagram to you. So for this case, I'll consider here two objects. As you can see, suppose let us consider this is an body, this is an object, and this is another object. And let us suppose this object has got mass m1 and this object has got mass m2. Understand? This has got mass m1 and this has got mass m2. The velocity of the body, suppose this is going to be your u1 and this is going to be your u2 initially. So they are not colliding now. They are at, with a condition that in this case that u2 will be greater than u1. Now they are about to collide between them. Now they will face a collision. They will go through a collision. So this is m1, this is m2. Now they have been colliding each other. So once they will collide, what will happen? That their velocity will be changed. Is that clear? Their velocity is going to be changed. So after collision, suppose the mass will not change. Mass will remain constant. This is mass is m1, and in this case mass is m2. But this particular this situation was before collision. Before collision, and this is during collision. This is during collision. Now after, once they collide, so this will be after collision. So after collision, what will change? This u1 is going to be changed as p1, u2 is going to change as p2. That means their velocity will also change. So this is the simple pattern in order to prove the law of conservation of momentum. So what we want to prove, actually, we want to prove the total momentum of this body before collision will be equal to the total momentum of this body after collision. Momentum will not change. The momentum will remain constant or similar. So in this case, what will happen? That in this regard, during the collision, what will happen? That this body will apply a force on this particular body. As a result, this body will also apply a force on this body. That means M1 will give a force on M2. Similarly, M2 will also give a force over M1 according to Newton's third law. So if I consider that this force, this is going to be your F. This force is going to be force on A by B, and this is going to be force on B by A. So if I have considered this object is, this is A and this is B. This is object A and this is object B. So what is the situation now? That A is exerting a force on B. As a result, B is also exerting a force on A. So this is FBA and this is FAB. Is that clear to you? So this is the diagram. Now if I go further for this thing, so if I write that now from the diagram, FAB, what is FAB now? FAB is the force on B by A. FAB is the what? Force on A by B. So this FAB, as you can write from the Newton's second law, that this is going to be your M1, sorry, this is M1, is M1 V1, M1 E1. Yes, so you can write this is M1 V1 minus M1 E1 upon time t. So what do you mean by it? M1 V1, this is your MV. So as you know that if you multiply this M and V, it will become what? Momentum. And if you do these things, I mean mv by t, that means this particular term will be what? Rate of change of momentum. And according to Newton's second law, the rate of change of momentum is equal to the applied external force. So FAB is going to be the equal to rate of change of momentum, that is m1 v1 minus m1 e1 by t. I am not going to discuss these things so critically, as you know, as you have done this thing in class 9 and earlier. So I am just going to give some hints about it. So this is FAB. Similarly, if you write FBA, this FBA will be M2 V2 minus M1, this M2 V2 minus M2 U2 minus M2 U2 upon T. Remember, these two terms has come from the Newton's second law, that the rate of change of momentum will be equal to the applied external force. Now in this case, this is FAB and this FBA. If you go to see the Newton third law, what you will find that this FBA and FAB are opposite. So as you can write, according to Newton's second law, according to Newton's third law, what according to Newton's third law, that FAB is equal to minus FBA, isn't it? And these things we know. FAB minus FAB is equal to minus FBA. They are equal and opposite. So we can write, if FAB is equal to minus FBA, so we can write, therefore, in the place of FAB we have found this is, and in the place of FB minus FBA we have to put these things. So from this particular equation we can write M1 V1 minus M1 E1 upon T is equal to minus M2 V2 minus M2 V2 M2 U2 upon T. These things you can write. If I further simplify these things, I'll find that here the T we can cancel out. So we'll have M1 V1 minus M1 U1 is equal to minus m2 v2 plus m2 u2. The things will be like that. Now if I further simplify, then these things will be like that, that this is minus m1 u1. So if I bring these things, m1 v1 plus m2 v2 is equal to like that. Hence m1 v1 plus m2 v2 is equal to m1 u1 plus m2 v2. So you can write further, therefore I can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So we have found that total momentum after collisions is equal to total momentum before collision. That means hence the momentum is conserved. There is no change in momentum after collisions and before collision. This is the proof of conservation of momentum. As I told you that the momentum of the body, momentum of any two body before collisions is equal to the momentum of any two those bodies after collisions. Am I clear? So this is all about conservations of momentum. One more thing we have studied in case of Newton's first law, that in the absence of external force the change of momentum is zero. I have discussed in previously on this class, but now you have come to know that conservation of momentum states that the momentum of any two body will be before collisions is equal to momentum of this two body after collision. So this is a very simple thing you have studied in class 9 earlier also. We can prove these things by many ways. There are so many proof on this thing, so we'll come step by step. If you require, inbox me. I'll try to clear all that out. Thank you so much.